In this video, we're looking at one more example of the comparison test. For this particular example, the same rules kind of apply. Now, in the last few examples, all we did was kind of look at the terms and simply ignore one of them. We ignored it in such a way that it helped us simplify or condense the problem down that we had. So in this case, it makes sense for us to ignore this term, because I should be able to make a conclusion about the concept of this term right here being, again, the defining factor of how it makes things smaller or larger. Again, if you have difficulty with this, the first step that you can start with is that this term here has to be larger than, logically, 2k to the fourth minus 1. So I know that this is a very clear and true statement. Now, if I end up dividing both sides by k cubed, this inequality doesn't change. Again, k being a positive number, this inequality stays stagnant. Now, the kicker part here is that when I try to flip the fractions, it's important to note that I'll basically have to multiply both sides by this thing on the bottom, this thing on the bottom, this thing on top, this thing on top. It means that what's going to happen here is I'm going to transition this whole thing to basically be this thing on top, where it's like this, but if I flip it, I have to then flip the inequality. So the true statement is 2k to the fourth over k cubed is actually going to be smaller than that of k cubed over 2k to the fourth minus 1. And this should, again, make sense, because if the denominator value is larger, it's the larger values in the denominator, then I know that the overall value is going to be smaller. Again, it's got an inverse effect on the value overall. So this value being larger means that this overall value is smaller, where this value is smaller, the overall value should be larger. So this is the mathematical conceptual understanding of how I can compare what I'm given. Now, this allows me to say, well, this is the series that I'm actually working with and I'm actually starting with. Again, I'm kind of ignoring this -1, and this is the series I brought to the table by ignoring the -1. The question is what is this series? Well, this series is simply 2k to the, sorry, that's wrong. I didn't write that right. That should be k cubed, and that should be k to the fourth, and that 2 should be in the denominator. I don't know why I didn't flip that at all. But so it should be that term there, so that should be k to the power of 3 divided by 2k to the fourth. But that series, if I simplify it correctly, is simply 1 over 2k, which is the same thing as 1/2 times the series of 1 over k. Now I'm mathematically allowed to do this because I can factor a constant out of a series or a sum without any ramifications. It's when I start pulling the variables out of the sums that things all get kind of wonky and inappropriate. So, with this statement being identified and clear, this is the thing I'm trying to compare this thing to. So, because this term is really the same as 1 over 2k, I can say that, well, given this statement is true, by the comparison test, compared with, and it's important to note that I am writing it different ways, by the comparison test, compared with 1/2 the series of 1 over k, harmonic, and that is harmonic. It's important for us to know that off the top of our heads. Given that it's compared with a harmonic series, which I know to be divergent. And again, before I move on, let me just double check. This thing is less than this one. This one's divergent. It forces this one then to be divergent as well. Then, therefore, the series we were given, k cubed over 2k to the fourth minus 1, is also divergent. Again, if I end up having this inequality flipped when I'm playing with a divergence series, then I can't conclude anything about this comparison. So it's so important that the setup we have matches up exactly with what we need. This is less than this one, and this one is divergent, therefore this one has to be. If this one is convergent and it's less than this one can do whatever it wants. There's nothing telling it to go up or down or condense into a single term. So it's so important that we have that comparison perfectly laid out, exactly like that of the comparison test statements. Again, if my function I was given is less than b sub k, then the one I'm playing with, the one I'm bringing to the table, must converge. If my series that I'm given is greater than that of the one that I'm bringing to the table, then the one I'm bringing to the table better diverge. Otherwise, I don't have any clear conclusionary statements that I can make.